All right, we have recording started. So I would like to welcome you to our talk. It's called A Fast Intro to Fast Query with ClickHouse. My name's Robert, and I'll be doing the talk today along with the demos. So this is the first in a series of webinars that we'll be doing to talk about use of ClickHouse and get people up to speed. We'll be going much deeper into the details in future webinars. This one is really just to get you started, as you see, and teach you a little bit about how to run queries. And then, of course, to answer any questions you may have. Let me talk a little bit about Altinity. So we're the premier provider of software and services for ClickHouse. The company's incorporated in the UK. We have a distributed team in the US, Canada, and Europe. We are the main US and European sponsor of the ClickHouse community. As you may know, if you've used ClickHouse already, it is developed by Yandex, and they, of course, have a very large Eastern European community. We're focused on developing the community in other parts of the world. Our offerings include enterprise support for ClickHouse and its ecosystem projects. So if you have a deployed system and need anything from 8x5 to 24x7 enterprise support, we're the people to do it. We also develop software. This includes Kubernetes provider for ClickHouse, a Kubernetes operator, cluster manager, and various tools and utilities. And finally, we do POCs and training for people who are just coming up to speed and need help getting projects off the ground. So that's our offerings. We'll come back to that if you have questions, but for the rest of this talk, it's going to be largely technical. Just a little bit about my background. I've been working on databases since 1983, and I think that ClickHouse is number 20. I've worked with a lot of them. Obviously, it's my favorite right now, and I think you'll see that as we go through the talk. So let's go ahead and dig in. So I think as we begin to talk about analytics in general, it's useful to take a step backwards and just think about the problem that we're solving. And one of the things that's really interesting, if you have been in the data management business, is how much it has changed over the past 2 to 3 decades. And the main change that we see now is that whereas previously people were dealing with data sets that might run into 100 or 200 million rows, what we now find is that businesses are having to deal with these massive pools of automatically collected information that contain useful insights that you can use to run your business, but you have to be able to process the data to get them. And we refer to that as a change in the shape of data. So if you look at the applications that are built for this new era, they have a common success factor, and that is the ability to discover and apply business critical insights in real time. And not just from any sort of data set, but from data sets that start out at petabyte size. So that's kind of high and sort of a high level example. I think it's useful to consider something more concrete. So let's look at a large web property. They're going to track click streams for a number of reasons. They're going to, first and foremost, do things like calculate click-through and buy rates. So somebody arrives on the sites, they click around, where did they go? What's the percentage of people who go from just clicking around to actually selecting something to actually purchasing? That funnel is something you want to analyze and be able to figure out how to make it better. Another thing you want to do is guide ad placement. You may be looking at impressions, considering different placement algorithms. Again, all based on behavioral analysis. And then a final thing that you might want to do is just optimize your e-commerce services themselves. And this was actually pretty much the problem that Yandex, which is the Russian, kind of like the Russian Google, was faced a few years ago. And when they set out to solve it, they also added some constraints, which were to run on commodity hardware, to be very simple to operate, to have super fast interactive query, and to avoid encumbering licenses. And you might say that in doing this design, in a sense, they sort of had the model of MySQL in mind, which is, very much meets this, but obviously it only works on smaller data sets. And as you look at the databases, sort of scan the environment of databases that are available with that problem in mind, with the constraints in mind, one of the interesting things is even though the analytic market is very, very crowded, most of the options that are out there do not either do not solve the problem, or if they do not meet all the requirements or the constraints. So, for example, you consider Snowflake, a cloud database, cloud native analytics solution, really great product, but it only works in the cloud. So it means that if you have stuff in an on-prem data center, it's useless. Another great product, Vertica. We like to call this a legacy analytic product. So it's licensed, typically runs on-prem. These are expensive to run. They scale relatively poorly on commodity hardware, so the expense is not just licensing, but the fact that you often have to buy very high quality software to run it. Look at, of course, the Hadoop ecosystem, including things like Databricks. These can deal with massive quantities of data, but they're relatively resource intensive and they give slow answers. So if you're looking for something where you're getting answers back in less than a second, this is not your solution. And then finally, there's specialized databases like InfluxDB or Elastic, which solve particular point problems well, but they're often complex to manage and can be very resource inefficient as you extend it to more general problems. So with that in mind, that's the environment now. Yandex had a similar, saw things similarly at the time that they began to develop this. What they came up with was ClickHouse, which fills those gaps that are not met by the current products, but also does much more besides. And so here's just some general reasons where if you met somebody and they said, hey, why, and you ask them, why is ClickHouse good? Well, there's a number of things that it does well. First of all, it understands SQL. So if you're used to dealing with SQL queries, and I think if you're on this call, you're probably somebody who's used SQL before, this is going to seem pretty familiar. It's portable. It runs on anything from bare metal to cloud with containers in between. It stores the data in columns. So this is actually very important because it gives us enormous efficiencies in the amount of IOs that we have to do on read. It also means that we can do those IOs both for read and writes very efficiently by always doing sequential IO. So, and this is important because it allows us, excuse me, to use hard drives very efficiently as well as other storage types. It has parallel and vectorized execution. So parallel in the sense that both within a single host, we use all cores and all hardware threads on those cores. And then across host, we have the ability to parallelize the processing very efficiently. Vectorized means that we're focused on using processing things in vectors that can take advantage of SIMD instructions. So that's single instruction, multiple data. And these can lead to enormous efficiency gains. Scales to many petabytes. It's open source, so no licensing problems, and it's way fast. And I think that when people talk about ClickHouse, it's the speed that really impresses people. And that's the number one thing that people mention. So what do we mean by way fast? Well, here's one of our favorite data sets. It's airline on-time data, comes from the US government, and it basically tracks the on-time performance of the US air carriers over the last 30 years. And what we have here is a query which is just looking at the destination airports, counting them up, and then checking the average delay minutes for each of those airports. And we're basically looking for the airports that on average over this time have had the biggest delays. So we run this query and it comes back in a second. It processes over 170 million rows. And then we get our answers. So this thing is really quick. This is on an Amazon machine that you'll see in a few minutes. Not particularly capable. It does have fast storage, but it's definitely not a monster by any means. So this is what we mean by fast. And we'll come back to that query in a bit, but what I'd like to do is now sort of turn and look at how we get this installed, because that was one of the main goals of this webinar, which is to help you bring this up quickly. I should mention, before we dive into that, I just want to touch on the use patterns for ClickHouse. So you have this database, it's very fast, has these other properties. How do people typically use it? The first pattern is to build very large data warehouses for online services as well as in-house apps. Good example, if you're familiar with Cloudflare, their DNS analytics, their website analytics, and their log management is run on a very large ClickHouse cluster. They have about 100 nodes. So that's a very common use case. Yandex does that. Many other users do as well. It's a built-in data warehouse for installed analytic applications. It is surprising how many people still build apps that are actually installed on site. If you need a data warehouse to put into that app, ClickHouse is very convenient for that because it's easy to set up and manage. And we see actually a very large number of people doing that. And then the final thing is you can just use it as an exploration tool. And that's actually the focus of this talk, which is just bring you, get you up and running, show you how to load data, and then play around with it. So with that, I'd like to go ahead and dive into some of the installation. And the easiest way to get started is using Docker. So here's a slide that shows how to do that. But rather than go through slides, I now like to switch out and let's just go ahead and do a demo and track how we can get this thing set up. So I'm logged into a host just like the one that query was run on. It's up in Amazon. That's convenient because I can just blow it away when I'm done. And I'm on a host that does not have anything installed at the time. So let's go ahead, and I'm going to go ahead and run that Docker command that I just showed you a minute ago. So no images, pre-cached. This is pulling it down in real time. Boom, pull is complete, and we now have Docker up and running. So if we do Docker PS, for those of you that are Docker fans, you can see that you now have a ClickHouse server running. So the next thing we're going to do is we'd like to run a client. We don't have any client software installed on this, so we're going to go ahead and exec into that container and just run the standard ClickHouse client, which is a little program that allows you to talk to ClickHouse. And so here's your Docker exec command. Let's go ahead and jump in. And now we're connected to ClickHouse. And so, for example, we can see what version we have. It already showed us, but we can also ask. So there we are. That's our first query. And this is a good time to take just a little bit of a tour of the kinds of things that you find in a ClickHouse database. So first of all, I mentioned that there's some similarities to MySQL. And if you've used MySQL, you're going to feel somewhat at home. So for example, I can see what the databases are. I can just do a show databases command. There we go. I see a couple of databases. I can use the system database. That's the database that contains all my configuration tables. And so now that's set, that's my environment, and all my queries, if I give a table name, it will go to that database. And I can show tables, just like MySQL again. So this gives me the list of tables. And I can go ahead and describe individual tables to see what columns they have. So let's just do, actually, table engines will be a good one. There we go. So that gives a very simple description of this table, which is just describing engines. We'll talk more about those in a moment, but it's very simple. So that's basically the sort of has the thing up and running, and we could now actually go ahead, create tables, add data, and play around with. And for dev purposes or testing, that's actually very convenient to do. What I'd like to do, though, actually is to quit out of this and do a real installation. And in this case, what we're going to do is go ahead and pull down the Debian packages and go ahead and install a real server on this system. So let's go ahead and get an appropriate apt install command. So here we're doing an installation, and one of the things I'd like to point out is we are limiting the version to something that we call the Tennety Stable version. One of the things we do at Altinity is we track which is the latest and greatest. Obviously there's the latest and greatest that's fresh out of the build system at Yandex, but there's also the latest and greatest, which is really the one you want to use for production deployments. 18.16.1 is currently the one that you want to use. So we'll go ahead and pull that down. So again, you'll see this coming down. It downloads about 100 megs of data. So it's coming down pretty quickly because we're on Amazon with good connectivity. We're setting up. And just like that, we've finished the installation. The server is not running yet, so let's go ahead and start it. So we've started the server, and at this point, we can go ahead and log into it. So we'll run the ClickHouse client from the command line. And here we are up and running. We can go ahead and do a select version as we did before, and this time it's 18.16.1. Let's go ahead and do a little bit of work here. We're going to create a database to hold sensor data. So there we go. And we're going to use that database. And what I'm now going to do is create a table in it. And you'll see this is, if you're familiar with the SQL create table command, this is going to look fairly familiar. So you have create table, it's called sdata for sensor data. We have some columns defined. Data types look a little bit different from other SQL implementations, but you sort of understand what they're doing. And then there's these things about the table engine, partition key, and an order by. And we're going to ignore those for now because we're just doing copy paste the samples, but we'll dig into those in just a minute. So here we go, create the table. Oh, actually, it looks like it's already existed from a previous example. So we'll do drop table sdata. There we go. Let's try that query again. There we go. Okay, created. And now, since we're investigating and want to just try putting some data out, let's do a couple of inserts. So the insert format is pretty similar to what you're, a little bit different as you dig into, but generally speaking, quite similar to normal SQL. So basically a couple of rows added, and we're going to add a couple more rows. So there they go. And so now we have 4 rows in the database. Now, this is not the way that you normally load data, particularly if you have very large amounts. It's more common to load CSV, so comma separated values. That's in fact how we load that airline data set. So let me just illustrate how you do that. So I'm going to create a simple CSV file. So basically just cat some data into CSV. Let's just go ahead and look at the command. So this is in Bash, we're creating the CSV file. We'll just cat it to make sure it's actually got something. There it is. And then what we can do is, the way that ClickHouse works is you go ahead and pipe this file into the ClickHouse client with an insert command that's added. And so here's what the command looks like. And what this says is, go ahead and it's going to cat the file, so pipe it to ClickHouse client. And we want it to go to the database sense, and then we want it to execute this insert. And what the client will do is it will then glom the data that you're piping into it after the insert. And if we do that, bang, it works just like that. So now we can go back in and have a look at what's going on inside the database. So here we are back in. Let's use the database sense. And we're going to go ahead and select star from sdata and see what we've got. And at this point, if you've used other databases, you immediately notice that ClickHouse is a little bit different, because instead of a tabular format, we get this data divided up into what we call parts. And so one of the questions that you may have is, what's going on underneath? We're going to look at that in just a minute. But what I'd like to show you is another interesting property, is that if you wait long enough in ClickHouse, this data will actually merge by itself, so that you may start with a large number of parts, but they'll become smaller. I'm going to force that using something called an optimize table command. And we will go ahead and so we'll do an optimize table sdata. Okay, and if I do that same select again, voila, you see that a couple of the parts actually merged into a bigger one. So what's going on here is that ClickHouse is actually merging data in the background. And what I'd like to do is this basically, at this point, we have a working server. So at this point, I'd like to stop the demo, and we're going to come back and talk a little bit about how ClickHouse manages data internally. So let's go ahead and bring the slides back up. And we can go ahead and skip over the slides. We'll post these later. They show the commands that I executed. So for example, the table creation and data insertion, loading CSV files, so on and so forth. And then of course the result that you get when you select data and how you see these parts, and then you can see them merge. So what's going on here is that you're seeing the behavior of what's called a merge tree table engine. And this, here's the statement that we executed. Let's now look at some of the properties that were associated with that table. So we have first of all the engine, which is merge tree, and this is the workhorse engine for organizing data in ClickHouse. We'll talk about its behavior in just a second. You then have this thing called a partition key, and what this does is it's telling ClickHouse how to break the table up into parts. There won't be just a single table object. There'll be parts which are spread out over over storage, and this is one of the fundamental ways that ClickHouse supports parallelization on a single node. And then finally, there's an order by, and that tells us, okay, how are we going to sort the data within each part? Because ClickHouse has to pick a sort order in order to, and then it depends on this to also index the data, and we'll see how that works. So let's look quickly at the merging. So what we were seeing in that merging, if you had gone out to the file system, and you can actually do this, it's fairly straightforward, you would be able to see that there are a couple of, when you start adding data, you see these directories started up, and they have the partition key. And so the idea is that the merge tree, when you insert the data, it quickly sticks it into parts, one for each block of things that you're inserting. And what that means is you then get very fast write, because we don't make an effort to write the data in a totally optimized way. What we do is, after the fact, ClickHouse will, in the background, merge the small parts into bigger ones, which are then more optimized for reads. So you basically get the benefit of the best of both worlds. You get very quick writes, because we don't spend a lot of time sorting and indexing. We just, throw stuff in as quickly as we can. You can immediately query it, as we saw, but over time, it then merges so that your reads become much faster. This is the fundamental behavior of the merge tree engine. One other thing we can do is just look at what's going on inside one of those parts. And this is also important to understanding how the data are actually organized. So what you'll see if you go and look inside one of these parts is you'll see a file called primary.idx, and then you'll see a bunch of .mrk and .bin files. And those second sets of files, they represent each of the columns. So for each one of those, you'll see a .mrk file, which is index pointers into it, and then .bin, which is the actual data. And the way that this works is this is a sparse, this is not a B-tree index or anything complex like this. This is what's called a sparse index. And the idea is that if you need to have, to select stuff, say around a certain date, what it'll come in is it will select the stuff that's before it, because in this particular index, if you actually go look carefully, it's actually only logging about every 8,000 entries. It will select some that's a little bit before and some that's a little bit after. And then it'll go over to these .mrk files, and that'll tell it where to begin and end in the array. So ClickHouse tends to read a little more data than it needs to when it's actually doing selects. And in fact, if you do point selects, you could end up reading quite a bit more data. But overall, this is a very, very efficient structure because it's extremely compact and we don't have to do a lot of I/O to read it. So that's basically the index structure and the sort order. One of the things that's useful to read out of this is that there is only one index. There aren't secondary indexes in the sense that you have them in a database like MySQL or Postgres. The other thing is there's one sort order. So that means that if you have things that end up needing to sort large quantities of data in a different way, you need to think of a different way of handling it. And we'll touch on that at the end. So with that, you can follow how query works on a single server. And basically, here's just an example, a simple query. We do a select, we have a where clause, and what ClickHouse will do is it'll look at this query. It will, if it can, restrict the parts to search. So if it turns out that that M date is in the is something that's in the index, in this case, it probably would use this. It'll identify the parts to search. It will then blast out queries in parallel using all available cores and all hyperthreads, aggregate the results, and hand them back to you. So that's the basic query format for this. So so I want to just touch on this because in this particular talk, we're kind of focused on single node computation. As you go to multiple nodes, I just want to mention how the model for that works. You can look up the actual examples elsewhere, and we'll certainly talk about this later. But if you did have a lot of data and it was more than you could put on one machine, or you wanted to take advantage of the processing power of multiple machines, you would divide the data into what's called shards. And the way that this works is you keep those local tables that we just saw defined, and you define an umbrella table across them using what's called the distributed table engine. So, and in that case, the distributed table engine basically knows where, part of the definition is to link to a configuration file that tells where all the underlying tables are located. And so the query comes in to this distributed table. ClickHouse will break it up into pieces and send it out to each of the shards. There's an addition to that, which is that if you are big enough that you have shards, you probably are big enough that you don't want to lose them. So there's another kind of merge tree table, or merge tree engine, which is called the replicated merge tree. And this basically allows the local tables, which are underneath the distributed table, to have multiple copies. And the way that it works is that it uses Zookeeper in the background to kind of do the accounting of where the replicas are and who has received data and that needs to be propagated to other replicas. And the distributed table then is smart enough to know that as we come in and fulfill this query, that not only do we have shards, but there are multiple copies of each shard, and we can just pick one for the query. So that's the basic organization. What I'd like to do now is talk a little bit about performance, and rather than going into, I want to just check one chat thing. Rather than going through boring slides, it's more fun to actually run some real queries. So what I'm going to go ahead and do is run those queries now. So let's go ahead to back to our window, and let's in fact get a couple of them. I want to show something because this up here on the left side, or on the right side, we're running HTOP. That's one of my favorite top utilities. It will basically, what you see here is the cores, or the virtual, well, what Amazon thinks of as virtual CPUs. They're really cores with hyperthreads. So we'll see those get active as we run queries. So let's go ahead and connect to a server that has some really interesting data on it. And what I'm now doing is connecting to another server which is loaded with this airline data set. So let's go ahead and log into it. Show databases. And there's airlines, so we're going to use airline. Look at the tables. So this is a sample data set that you can get yourself. We're actually going to be publishing an easily consumable version of it in the near future. But it has a list of airports. That's kind of a small data set. It basically allows you to translate an airport abbreviation like SFO to a real place name. That makes the output nicer sometimes. The real heart of this is the on-time data set. That's where the airline performance data is. So first question we can ask is how much do we actually have? So let's have a quick look. So let's go ahead and select count star from on time, and don't blink because you will miss this. So basically, this does the count of the data set, and it comes back in 23 milliseconds. That's pretty impressive. Now, if you're a database person, you'd say, oh, okay, you guys probably cheated and read an index, and that's essentially true. We didn't actually have to read that much data to get this number. But let's go ahead and run that fast query that I showed you a few slides back. So let's go run that and see how that runs. And you may see in the HTOP, you may see the threads or the vCPUs firing up. So off it goes. We'll start it. You may see it. It runs pretty fast, but this basically, there we go, in 1.184 seconds. We scanned through 173 million rows, and at a rate of about 150 million rows per second. So this is basically scanning through a tremendous amount of data to get this to work. So that's a simple example of the speed. Let me show you some other ones. Just basically, so this is 170 million rows. It's not a trivial data set. It's of course much smaller than production data sets that at least some of you on this call have. Let's just look at a few other examples. What we were doing, let's pull that query back. That was too fast. So we're just going to select the carriers and find out how many flights they have in this database. And Southwest, that's WN, has the most flights, followed by Delta, followed by AAUA, and so on and so forth. So so we can do that kind of query. Another kind of interesting query that's more complex is just to ask, well, you know, year by year, how many flights are canceled or delayed? This is beginning to be a little more interesting data analysis. So let's just look at that select. So we're going to split the flight dates out by year. We're going to basically take the number of canceled flights. So canceled we're just going to count that up and divide it by the count. We're going to look at at whether things were delayed by 15 or more, again divided by the count. So fairly, you know, a simple query, but doing something interesting. We'll run that. Let's see how fast that takes. Oh, pardon me. So get 31 rows back, and that came back in 1/4 of a second. So this is really useful information here, and obtained very, very quickly. So gives you an example of how you can actually test hypotheses very, very quickly. And in fact, we had to process the entire data set for this, so this was kind of a long query. What we can do is go ahead, if we just want to know 1 year, we'll go ahead and we'll lower it quite a bit. Let's go ahead and again do this shorter query where we put a where clause in, and we're actually going to just select 1 year. How much faster would this be? Well, don't blink. It's really quick. So in this case, we were choosing something that ClickHouse correctly recognized, allowed it to take advantage of the fact that it knows how the data are divided into parts. It's somewhat interesting how it did this computation internally, but it read far less data. It recognized it only needed to scan 5.5 million rows, and we get the result back almost instantaneously. Let me show you one final example that illustrates how you can make queries faster. Obviously, you can do it by having a where clause and reducing the amount of data. Another thing is you can actually change the structure of the queries themselves. So here we have an example of a query that what we're going to be doing is asking that same question about who has the biggest arrival delay times, but in this case, we'd like to actually, instead of having EWR, we'd like to have a real airport name so that we can make it a little bit more human readable. So we're going to do a join, and ClickHouse supports joins with left and right tables. So off it goes. And this one's kind of quiet, or it gets kind of quiet, and you can see over in HTOP how it ran the cores up all to 100% each and brought back the result in 4 seconds. And now, of course, we have proper names, and we see Newark is the slowest airport for arrival times. This query can be improved considerably, and this is actually something that we do a lot of when we're working with customers. And one of the things about that query was that it was actually doing the join while it was scanning the rows. That means that we had to process a lot more information for each row before we went and did the grouping. We can improve that by pushing that initial scan down into a subquery. So let me show you an example of that. And we'll go ahead and do this select. Off it goes. And that comes back in 1.2 seconds. So what that did, just to look at the query, is we went ahead, we did our select, but the core, the center of that, the main distributed query, the place where we're doing the parallelization, actually reduced the number of columns that we had to look at. And that made the query quite a bit faster because we simply had to scan less data, and then we did the join on the airports table at the end when we only have a couple dozen rows, in this case 10. So that's an example of how you can optimize queries. So there is one final thing about performance that I think is worth mentioning, and let's see if it works correctly. I'm going back to the laptop that I'm using for this, and this is not a high performance machine. I've actually got the same data set loaded on this laptop, and this is an old Dell laptop. It's about 5 years old, has a Sandy Bridge, a pretty weak Sandy Bridge processor. It has an SSD that is so slow that when I looked it up to get a performance comparison with other devices, modern ones, this one ranked as 0. So let's do a show databases, and we'll just illustrate the fact that we can do these queries even on a very small laptop. So here we have show databases, use airline, and let's just do a select count star. Again, very, very small computer. Okay, it did the count in about 4 seconds. Let's just do something slightly bigger. We'll just do carrier. We'll just see what the carriers, how many flights each carrier has. And we'll just group by carrier. And order by carrier. So a nice list. Oops. Oh, got the name wrong. There we go. So you can see it takes a little bit longer, but it got this in 2.5 seconds. When I run this query on my nice beefy Amazon machine, it comes back in about half a second. So it's 5 times slower, but the point is I'm dealing with a data set with 150 million rows or 170 million rows on a very, very low-powered laptop. So that concludes the demos. Let's just go back and kind of look at the sort of some final information to get you started. So you do have that basic information about tuning queries. And I just want to, without repeating the examples, a really important tip is when you start to run these queries, go ahead and look at the ClickHouse server log. It's in var log, and this shows the query plan. So you can actually see ClickHouse doesn't have an explain, but it does show the query plans. This will be available under the covers. And that's, for example, how I was able to look at these queries and figure out, hey, this one here, the first one scans 355 table parts, and the next one scans 12. And then usually with ClickHouse, the amount of data it scans directly corresponds to how fast it is. So you can go look and figure out whether you're using the index, for example, or the partition key. The optimization of the joins, again, we talked about that example, joining inside, just having a straight join and then grouping afterwards is not so good with ClickHouse sometimes. Pushing the most expensive part down into a subquery that minimizes the I/O is the way to go. And this is for people who are used to query optimization, this is a little bit backwards from the way that queries work in databases like Oracle or Postgres. You're usually used to a query optimizer that tries to put the littlest thing in the inner loop. With ClickHouse, it's sort of flipped. You want to put the big thing in the inner loop because that's where you're going to get really great parallelization, and then you tend to get those joins that happen outside of it tend to be serialized. ClickHouse is not very efficient on those, at least not yet. All right, so much for SQL. There's a bunch of other features in ClickHouse that allow you to create very fast queries. Dictionaries are something you should look into if you want to do a lot of joins. ClickHouse can do right and left joins, but it can't do an infinite number of them. It basically has 2. If you need to do more, you need to basically push join conditions down into subqueries. Dictionaries solve that problem. They give you lookup lists that you can refer to, as many as you want, in a single select. Materialized views are another very powerful feature. You can basically, as you load, you can construct materialized views, and then ClickHouse will populate them. This is how you get data sorted in different orders, aggregated in ways that answer questions in advance, like, hey, what's the last sensor data reading I got? That's something that materialized views work very well. You can even have materialized columns, which are ClickHouse, which are kind of an interesting feature that will allow you to pre-compute information very efficiently. ClickHouse doesn't have arrays or window functions or windowing functions, but it does have arrays. These are very efficient. In a future a webinar, we'll look into them. There's some real magic around them. And then it has a raft of specialized functions and SQL extensions because it was built for doing this behavioral clickstream analysis. So for example, it's histogram functions, all sorts of useful things. And then finally, lots more table engines. There must be about 30 of them. So they do everything from maintain different kinds of materialized views all the way to reading from Kafka queues. So that's inside ClickHouse. You also have a bunch of good ecosystem tools, client libraries, the usual suspects: Java, JDBC, ODBC, Python, Golang. I use Python a lot personally. There's a very good driver. You can read about it on our blog. There's Kafka table engine to ingest from Kafka queues. A lot of people also build external clients. There's great visualization tools. I'll show you an example in 1 second. You can integrate with the Python data science stack. And one of the things that we're working on right now that we'll be talking about more is a Kubernetes ClickHouse operator. So it's actually pretty easy to set up ClickHouse on Kubernetes clusters. And just speaking of the tools, I just want to show you very briefly Grafana. This is a Grafana dashboard that's running on about 20 years of the data that we were just looking at. It's actually running on the same server. And again, it's pretty quick. If I just go ahead and refresh, you'll see it running all the queries. And the dashboard has to actually go out and recompute all this data. So it has to scan quite a bit of data. And as you can see, it goes very quickly. Very nice time series visualizations, things like delays and cancellations, so on and so forth. So that's a very powerful tool and something you should definitely look into if, among others, as you're using ClickHouse. Final thing, where to get more information. So obviously ClickHouse Docs, there's a lot of information there. There are some limitations, and that's something that we're working on. The Altinity blog is another place that I highly recommend, not least of all because we write articles on it. But we talk about how to really make things work, and so it's everything from how do people, solve particular problems when dealing with time series data, to integration with Python, to things like what was the process that people went through when they migrated from Amazon Redshift to ClickHouse, so all kinds of good stuff. And then on top of that, there's meetups and conference presentations. On the 2nd of April, we are going to have a very large meetup in Madrid, Spain. I think there's a couple hundred people signed up for it. We'll be at Percona Live in May. There's also San Francisco ClickHouse meetups, and we participate in many other conferences and meetups as well. Those are all posted on our site. But definitely, I encourage you, if you have people in the community that you can work with, definitely encourage you to meet up with them. And that's the end of the talk. Thank you very much for listening. If you have additional questions, please feel free to pop them into the question box, and I will hang around for a while and answer them. So thanks again, and for those of you that depart, have a great day. Otherwise, I'm here to answer questions. Okay, I don't see any popping up. Valerie, can you just do a quick check to make sure that the questions are coming through correctly? I do see the question and answer, but I would just want to make sure it's working correctly. Oh, how can you delete data? Okay, great question. So ClickHouse does not currently support the SQL update and delete commands. They will be added later this year. What it does, there's a couple different ways you can do this. There is a there is a couple ways that you can do this. One is, in fact, the most efficient way to drop data is to actually drop whole partitions. So I showed you that partition key, and there's a drop partition command that allows you to wipe them out. If you want to actually update the data, that's a different matter, because ClickHouse does not, once it writes a part, it does not actually go in and change it. So any changes that you do are going to actually have to be implemented by rewriting the parts into new parts to represent those changes. So there is sort of a moral equivalent of an update and delete command. It will be fully supported, you know, sort of in SQL 92 syntax in a future release. And then finally, there's other ways of thinking about this problem, which is that if you're deleting data because you want to show the current state of an operational database, another way to think about this is not to delete it at all, but instead put a flag on it, and that says, and in fact, there's something called there's a collapsing merge tree, which actually can allow you to build materialized views that will basically look across the values, for example, if they have a primary key, and will take out all but the last one. And so that allows you to have your cake and eat it too. You can have the values of the data over time, but you can have this materialized view that shows the current update, you know, sort of the up-to-date version of that row. So I hope that answers the question. It's definitely a very interesting one. There's a question here, can it do common table expressions? And I'm going to have to say I'm embarrassed. I don't know what they are. So if you could just give me a more of a hint, like an example of one, I can tell you whether we can do them or not. In fact, I'm going to all right, I'm just waiting to see if I get a qualification on that common table expressions. That's a good question. All right. Oh, it's really an ephemeral table. You know, the answer is I don't know. An ephemeral table. So, yeah, you know what I can do is if you want to send us an email to info@altinity.com, I will definitely get back to you on that one. My apologies. I just haven't used those before. So that's a great question. Yeah, thank you very much for asking. Any other questions that we can help with right now? Okay, well, I think we're going to go ahead and call it. Thank you all so much for attending today. We'll get back on that answer about the common table expression. And have a great day, everybody, and we hope to see you on more of our webinars in future. And definitely, if you have further questions, want to talk about ClickHouse, don't hesitate to send us email at info@altinity.com. We'd be delighted to talk with you. Thank you very much and have a great day.